Hello, Cappuccino. I was asked to make a helper video for the differential equation word problems. So I'm going to do problem number 1 and problem number 2, and I'll leave it up to you to try and do 3 and 4. I will try and make myself available tomorrow during class and office hours. And yeah, that's it. On Friday, I will be in class. You are not required to come to class on Friday, but I will try and make myself available. If not for the whole time, at least I'll be there at the beginning. And then if nobody shows up, I'm I'm going to keep working on my classroom because I have a lot of work to do here and I can't be tied to my desk if I'm going to get my work done. All right. So, the first problem says the value of an antique vase in dollars increases at a rate proportional to the time. Okay. So, for me, I like using X and Y. I don't like using other variables. So, I'm going to define what X and Y stand for. So X is going to be time and Y is going to be the value of the vase. So I'm going to start by defining my variables. Okay, so now I know the rate of change of the value. Okay, the rate of change, that would be dy dx. The rate of change of the value in regards to time is proportional. So that means I'm going to have some number k times time because it's proportional to the time, and time is x. So there is my differential equation. So if you look at the little information before the example, they give you some hints as to what kind of words to be looking for. So when you see rate of change, that means that you're going to have a derivative, dy dx. Proportional means you're going to be multiplying by a constant. Inversely proportional means you're going to be have a constant times 1 over x. And if you have a rate of decrease, it means it's going to be negative. So if you look back where it says key point 5.1, you can see all those little hints on how to set up your differential equation. Okay, so here's my differential equation. So now how do we solve a differential equation? We separate the variables. So I have dy is equal to kx dx, and then we would integrate both sides. But I got a little problem here. I've got this k, and so I know I want to get rid of this k at some point. So I'm going to be looking to see when can I get rid of that k. It's going to disappear at different places in these problems, depending on what kind of information you have. Okay, so but then basically what I would do is after I write my differential, I would then integrate both sides. When I integrate dy, I just get y. And then over here, I would get 1/2 k times x squared. K is just a constant, right? So I just keep it with me. X is my variable, so it becomes add 1 to the exponent, it becomes x squared, and then multiply by the reciprocal of the exponent. And then plus the constant of integration. All right, so I got too many letters here, right? I want to get rid of the k and I want to get rid of the c. So let's see what other information they give me. Okay, so it says 1 year after it was found, the value of the vase was $500 and it was increasing at the rate of $30 per year. Oh, the rate. I know the rate. So way back up here, I know the rate was 30. So 30 is equal to K times whatever the time was. Well, what was the time? It said 1 year after it was found. So that would be K times 1 is equal to 30. So what is K? K is just going to be equal to 30. Oh, so now I can go and replace that here in my equation that I already integrated. So I'm going to substitute in my 30 here for K. 1/2 of 30 is 15. So I have Y equals 15 x squared plus C. Well, now I still have this constant of integration. How am I going to get rid of that? Okay, they give me some more information. They say 1 year after it was found, the value of the vase was $500. Okay, so 1 year after it was found, I have the value of the vase. So when x is equal to 1, y is equal to 500. Okay, notice neither one of those numbers was a rate, so I don't have to go back to my differential. These I can plug into this equation and solve for my constant of integration. So I'm going to have 500 is equal to 15 times 1 squared plus c. So, okay, 1 squared, of course, is just 1. 1 times 15 is 15. I'm going to minus 15 from both sides, so I get 485 is equal to my constant of integration. Now I can write my whole equation. So my whole equation is y is equal to 15x squared plus 485. Okay, so now the last part of the question says find the value of the vase, that's y, when the vase is 10 years after it was found. So my x is going to be 10. So I'm going to substitute in x is 10 and I'm solving for y. So y is equal to 15 times 10 squared plus 485. And if you add that, multiply that out and add your 485, you get 1985, which thankfully is the answer we were looking for. So it was really helpful to have the answers on this one. It's like, yes, we got it. There it is. Okay. So that was problem number 1. So pretty tricky. You got to be looking for those keywords, rate of change, okay, or rate, looking for that word rate. Um, finding out what information do you have that is, where does it go? The 30 was the rate. The next problem is a little bit different. The next problem is tricky in a different way. So problem number 2. The distance in m of a falling object from the top of a tower increases at a rate proportional to time. Okay, so I'm going to have my x and my y. My x is going to be time again. That often happens. And I'm talking about distance of my falling object. Okay, so the distance is going to be distance. Sorry, y is going to be distance. And I'm looking for the rate of I'm told that the rate is proportional to what? To time. Well, that sounds familiar. The distance is proportional to time. Okay, initially, the object is at the top of the tower. So at time 0, when x is 0, the distance from the top of the tower is also going to be 0. So there's my initial information. But notice I'm not given the rate. I don't know how fast it's moving. They don't say anything like that. But they do say initially it's at the top of the tower. So I think we can assume that it's not moving. The object is at the top of the tower at time 0. So at time 0, when x is equal to 0, I think it's pretty clear that the initial rate of change is also going to be 0. It's just at the top of the tower. Okay, that does not help me solve for k, though, because if I put in 0 here and 0 here, k could be absolutely anything, because 0 times any number is equal to 0. So not so much fun on this problem. The other problem seemed a little bit easier because I could solve for k quite easily. All right, so let's see what else we have going here. Okay, so it has been falling. Let's see. Where's the next sentence? Initially, the object is at the top of the tower. After 2 seconds, the distance from the top of the tower is 20 meters. Okay, so we have another point here. After 2 seconds, the distance from the top of the tower is 20 meters. All right, again, that's not going to help me find k yet. So let's go ahead and integrate. So I'm going to separate my variables. dy is equal to kx dx. I'm going to integrate both sides. So I get y is equal to, k is just a constant, so we're just going to keep it. I'm going to add 1 to my exponent and multiply by the reciprocal. That looks familiar. Okay, and then plus the constant of integration. So now I have 2 points, so I can actually kind of do a system of equations here. Let's go ahead now and substitute in our first point, 0, 0, and see if that helps us solve for k or c. So if I put in y is 0 and x is 0, can we solve for C? Aha, we can, because 1/2 k times 0 squared, it doesn't matter what k is. This whole term is just going to be 0. So 0 is equal to 0 plus C. So therefore, C is equal to 0. Aha! That's really helpful because now when I put in my second point, I will be able to solve for k. So I'm going to put in, oops, sorry. I'm going to put in my other point, the 2 and the 20. So I get 20 is equal to 1/2. K, I still don't know k yet. X is 2, so 2 squared. And C I know is 0, so I don't have to write anything. I could write plus 0, but it's not necessary. Okay, now let's simplify this. 20 is equal to half of 2 squared. Well, that would just be 2. Divide both sides by 2, I get k is equal to 10. All right, so now I have my constant, and I can put now all of this back into the original equation here. I know that C is 0, and I know that k is 10. So my equation now is y is equal to 1/2 times 10 x squared, or 5x squared. All right, so now let's answer the question. Find the distance from the top of the tower after 3 seconds. So the distance from the top of the tower is going to be 5 times 3 squared. 3 squared is 9. 9 times 5 is 45. 45, and it's meters. And that matches our answer. All right, so there it is. I did the first two for you. So go ahead and give the other two a chance. Look at that. I'm in my classroom and the motion sensor doesn't think I'm here. So it's telling me, okay, time's up. Off you go. So I hope that helps. Good luck with 3 and 4.